It's taken us a long while to get to where we are now when it comes to astronomy. Us humans have been watching the stars for over 5,000 years, exponentially seeing progress in our understanding of the cosmos. The Babylonians were the first to ask questions about the great beyond, curious to know what lies in the night sky and why they sparkle in the night. Now we have great instruments of precision like the JWST and the Hubble, among numerous others, to give us alarmingly clear images of celestial objects. But while things can be identifiable in our current age, there are innumerable mysterious objects that lurk in each corner of the solar system, let alone our galaxy and universe, including mystery-shrouded visitors. So, what of these mysterious visitors? Let's find out. Researchers say that the first known interstellar comet to visit our solar system may be the most pristine ever found. It never passed near a star until it visited ours, they say. Comet 2I Borisov was discovered by scientists in the solar system in 2019. The comet's speed and trajectory showed that it was a rogue comet from interstellar space. This made it the first known interstellar comet and the second known interstellar visitor after the pancake-shaped 1I Ohm. 2I Borisov, originally designated as C2019Q4 Borisov, is the first observed rogue comet and the second observed interstellar interloper after Oumuamua. Gennady Borisov, an amateur astronomer and telescope maker from Crimea, discovered it on August 29, 2019. The heliocentric orbital eccentricity of 2I Borisov is 3.36, and it is not bound to the Sun. In astrodynamics, the orbital eccentricity of an astronomical object is a number that tells you how far its orbit around another body changes from a perfect circle. A value of 0 is a circular orbit, and values between 0 and 1 form an egg-shaped orbit. 1 is a parabolic escape orbit or capture orbit, and greater than 1 is a hyperbola. The comet passed through the ecliptic of the solar system at the end of October 2019 and made its closest approach to the Sun at just over 2 AU on the 8th of December 2019. The comet passed closest to Earth on the 28th of December 2019. In November 2019, astronomers from Yale University said that the comet's tail was 14 times the size of Earth and stated, "It's humbling to realize how small Earth is next to this visitor from another solar system." In March 2020, the comet was observed to break apart, and later, in April, even more evidence of its breakup was reported. Now, scientists have found two new ways in which 2I Borisov is different from any other known comet. They wrote about their findings online in two studies, one in the journal Nature Communications and another in the journal Nature Astronomy. In one study, researchers used the European Southern Observatory's Very Large Telescope to look at the light that was scattered off the dust grains in 2I Borisov's coma, the envelope of gas and dust around its core. They specifically examined the polarization of this light, which is the way in which the light waves ripple through space. All light waves can ripple up and down, left and right, or at any angle in between. The greater the polarization of light, the more its waves all ripple in the same direction. Stefano Bagnulo, an astronomer in Armagh University in Northern Ireland, who led the study in Nature Communications, says, "When a comet passes close to a star, the radiation and winds from that star can alter the material on the comet's surface, like our skin when we go to the beach. The comet's coma polarization can be reduced by this." The scientists found the light from 2I Borisov's coma was very polarized, which means it was more pristine than other comets. That is, its surface rarely bathed in the light and winds from stars. The Halley-Bopp, which lit up the Earth's sky in 1997, was the only comet that previous research found had light as polarized as the interstellar visitors. Comet Halley-Bopp, officially designated as C1995-01, was one of the most widely observed comets of the 20th century and one of the brightest seen for many decades. On July 23, 1995, Alan Hale and Thomas Bopp discovered Comet Hale-Bopp separately before it became visible to the naked eye. Bagnolo continues saying, Halley-Bopp rarely went close to the sun, We think that before its apparition in 1997, it did it only once, about 4,000 years ago. So the material at its surface, when we observed it, was only slightly processed by the sun. However, the polarization of light across 2I Borisov was uniform, whereas it was not uniform for Halley-Bopp. This suggests that 2I Borisov may be the first comet ever found that has never been close to a star before it visited the solar system. This would make it a pristine relic of the cloud of gas and dust that once existed. Alberto Cellino, a researcher with the Astrophysical Observatory of Torino in Italy and co-author of Nation Communication Studies, said in a statement, "The fact that the two comets are remarkably similar suggests that the environment in which 2I Borisov originated is not so different in composition from the environment in the early solar system." Bagnullo stated that astronomers may have a better chance of studying a rogue comet before the end of the decade. The European Space Agency plans to launch the Comet Interceptor probe in 2029. This spacecraft will be able to reach another visiting interstellar object if one is found. Bagnullo continued, "Comets that never pass close to the sun are particularly interesting because their material is presumably the same as when our solar system was formed. It's important to study them." In another study, researchers analyzed data from the Atacama Large Planetary Observatory to gather clues about the comet's birth and its home system. The Billimeter Submillimeter Array, or ALMA, is from Chile and from the European Southern Observatory's Very Large Telescope. The study's lead author, Bin Yang, a planetary scientist at the European Southern Observatory in Santiago, Chile, said, "We want to know if other planetary systems form like our own, but we cannot study these systems to the level of their individual comets. Comets in other planetary systems are simply too far away and too small to be seen by our telescopes. We are very lucky that a comet from a system light years away made such a close visit to us." The scientists found that the dust in 2I Borisov's coma was made up of pebbles, some of which were about 0.08 inches, or 2 millimeters or more in width. Dust from comets in our solar system is usually made up of small fluffy clumps of material that range in size from about 0.00008 inches or 2 micrometers to nearly 39 inches or 1 meter wide. Previous research has shown that comets in the solar system formed in a wide area beyond Neptune's orbit, and when giant planets like Jupiter and Saturn moved to their current positions, their strong gravity pushed these comets out to sea. The researchers found that the compact nature of 2I Borisov's pebbles suggests that they were formed during cosmic impacts close to the comet's home star. Later, 2I Borisov was thrown out into interstellar space by the giant planets that orbited its home star. In the future, the Vera C. Rubin Observatory in Chile is expected to detect one interstellar object per year. This is expected to happen sometime this year. Yang said that the European Southern Observatory's Extremely Large Telescope, or ELT, which is currently being built in Chile, should help us learn more about these interstellar visitors. She concluded saying, "The future is quite exciting in terms of detecting and characterizing alien objects from other solar systems." So, what do you think? Where did this interstellar object come from? Is it more than just a mere comet? And will we ever be able to get a sample from it? Kindly let us know in the comments below. And as always, thanks for watching Space Age.